Um, so let's continue adding the deflections for beams. So in the last attempt of calculating, we didn't add it. That's why there became some problems with the first and second limit states. So to prevent again that mistakes, we will select the main beam. Then we'll select only our last beam, our last cell beam, so which was constructed last. Again, make the fragmentation, and we'll create then structural elements of these three beams. Generate it, make the end select all, then we'll select this second main beam, and select and generate. Okay. So now I will select again these beams and we'll add the deflection. Select one of them and add deflections on the ends of structural element. Selected. So maybe I need to add the properties. Maybe it will help. There's some problem, and if I will add delete all of them and after I will add okay, so first of all I need to delete the previous ones that it was added before and select it again, choose the create ends on the structural elements and add. So restore the models. Now I need to select the main beams, not main beams, secondary beams, I'm sorry, secondary beams. Make the fragmentation. Again, secondary beams, fragmentation. So here is my secondary beams. I will restore the model and will select the columns. Select model. Because it will be very difficult to understand where the columns is located. Because between columns I will need to make the deflections fixes. Structural elements. Now I will try to create from them the structural elements. and from this part of this. Now I will add the deflections on the ends of structural lines. Okay. Now I will restore the model and will choose the second beam or sailing beam. Make the presentation. I will change the route, and now I will select only second beams or secondary beams. I need to select it, and I will choose create at each node. We'll add the deflections. We'll restore models. Then I need add in additional elements. I need add the construction fingers, like it was in the previous scheme. So I will select the secondary, not secondary, second beam, and we'll add the fingers in position in both of these positions. Then I will choose this part of elements. This two. Because in this, it will be not right. I can't do the same. So I need to separately choose them, something like this. North and then inverse. Yes, just only in this way. What kind of, okay, I want to delete it, so I need to add. Okay, so I add it. Next, this position. Okay. Next one. So adding the fingers, it is important part of creating constructions, because the program should know which nodes are rigid, which of them non-rigid or semi-rigid, and so on. And the last one. Okay, so I finished adding the fingers to the secondary beam, and now I will add it to the main beam, in the ends of main beam. I will select the main beam, fragmentation, and like in the previous scheme, in the ends of main beam, I will add the fingers. And the opposite one. That's all. Okay. So I will finish the adding of fingers. And now I can make the pack of the model and make the calculation of them. So firstly, I will save my scheme with analysis of them and go to the elements. So I saw some problems with my second scheme. Maybe there are not enough sections of main beam, or maybe of sailing beam. 24, 27. Okay. What I can find here, I see that according to my handmade calculation, 24 I-beam, the number 24 of I-beam was enough to assure the stability and the bearing capacity of the sailing beam. But in this case, I need the 27 I-beam. So let's check, change the section of sailing beam or second beam from 24 to 27, 27A. Okay. And again, I will analyze these two schemes. In this case, I see that according to the first and second limit states, there are no problem. Okay. And according to the stability from local buckling, I need to do something that it was like in the previous one calculation, when I wanted to change it, but the program told me that there was no reason to change. It was a really big surprise for me. Now again, this question is open. Let's see. If we will select the main beam, and what we see? We see for both of them some problems that tell us that sections according to the flange, it will be enough to use 500 to 20, and here we need to use 1700 to 20. Okay, let's start. First of all, change the section of our web in the welded I-beam section. 1700 to 20 centimeter to 20 millimeters. Edit. Press OK and go to analyze it. Let's see what it will be. That's very good. Okay. No problems. Fine. Let's restore the model. Okay, so what if we will compare two of these variants, what we can see? We can see that according to the handmade calculation, in both of them wasn't enough sections applied into the handmade calculation. Because when we applied the section, it show us that they are not ready to work in this during the loading so huge loads like the normative loads, and we was able to change the sections, so increase the section. In my opinion, for me and you also, maybe your calculations will show the same results, just was only according to my task. If your calculation will show the same results, it is statistic. So, and the statistic tell us that calculation by using the software programs give us some more maybe confidence to say that it will be safety to prepare calculation by using the program, not handmade calculation, but program calculation. Because maybe there are some safety coefficients inside this program and they will more safety during the operation time, will be safety during operation time for the same cell beam, like in this case. So if you have questions or maybe some suggestions, I will listen to you and try to answer. No questions? Okay, so I want from you that you need to finish your calculations and you will be able to tell me about what type of answer you have. So is it really that computer program show some bigger according to the sections result and it was applied in the computer program, or in the handmade calculation? Okay? Okay. So thank you very much. So I will stop my demonstration.